All right, welcome to The Explainer. I am absolutely thrilled to be your master critic today as we dive into what I like to call a grade makeover kitchen audit. We are tackling one of the most notoriously misunderstood areas in the entire Cambridge Mathematics 9709 syllabus, which is 1.5 trigonometry. Specifically, we're looking at solving trigonometric equations. Now, I've brought along two conceptual apprentices to help us out today. First up, we've got Alex. Now, Alex has a bit of a habit of overcomplicating the recipe with a bunch of unanalyzed facts. And then we have Sam, who, well, tends to rush the baking process and completely forgets the crucial structural steps. So, together, we are going to audit a disastrous, low-scoring student exam response and completely turn it around. It's going to be a lot of fun. So here's our roadmap for today's masterclass. First, we'll look at the sour ingredients, followed by dissecting the disaster. Then we'll recook the response, jump right into an interactive taste test, and finish it all off with a 5-star presentation. Let's get cooking! Section 1. The sour ingredients. Let's analyze 1.5 trigonometry. Okay, let's examine the structural nightmare of a response we're auditing today. The question asks the student to solve the equation 2 sine squared x plus sine x minus 1 equals 0 for x between 0 and 360 degrees. Now, the theoretical architecture here rests on really precise definitions, but what we actually have is just panic on paper. So you have to ask yourself, why is trigonometry the most misunderstood topic in Math 9709? Well, when I asked my apprentices this, Alex immediately started throwing out these complex, totally unanalyzed identities, basically trying to substitute everything into tangent or cosine without any clear strategy whatsoever. And Sam, on the other hand, rushes the foundation entirely, factoring wildly just to get to a final number. And you know what? Both of these approaches completely forfeit marks. Okay, let's really dive into this distinction between superficial breadth and analytical depth, because here's the thing. Cambridge mathematics examiners don't just want a random scattering of memorized formulas. No way. They prioritize deep analytical reasoning. The whole assessment framework requires logical, structured thought, and principal examiner reports explicitly highlight this. They point out that candidates who reference cross-topic connections and actually show conceptual depth are the ones who achieve significantly higher marks, far higher than those who just memorize shallow facts and hope for the best. Moving on to Section 2, Dissecting the Disaster. Let's take a look at this messy response. Pulling out our virtual red markers here, the errors in this response are just glaring. The student was supposed to solve a quadratic trigonometric equation, right? But there is absolutely no systematic processing happening. It perfectly illustrates the principal examiner's top 3 mistakes. First, the student used the completely wrong approach for the context by failing to factorize correctly. Second, they completely forgot to check their format and presentation. And third, they completely ignored the specific 0 to 360 degree domain provided in the prompt, so they ended up tossing out answers that fall way, way outside the acceptable range. I mean, it's the classic trap for sure. So the really crucial point is how we actually fix this mess. Top-scoring candidates, they never panic. Instead, they rely on this critical triad mantra: deconstruct, solve, evaluate. It's a game changer. First, you deconstruct the question to identify exactly what information is given. Then you break it down into logical steps and solve it systematically. And finally, you evaluate. You check for reasonableness and explicitly justify your decisions. Honestly, this is the ultimate problem-solving framework. All right, we have reached the emotional climax of our audit. You absolutely have to understand this examiner alert. It is vital to grasp the method mark strategy. See, Alex previously thought that only the final answer mattered, but Cambridge actually rewards the process. If you show clear working and apply the correct theoretical foundations, like, say, clearly showing the substitution of u for sine x, you earn method marks. So even if a tiny calculation error throws off your final number, a beautifully structured process will literally save your grade. But, and this is a huge but, if you do what Sam did, rushing the process, showing 0 working, and just scribbling down a wrong final answer, this is exactly how many marks you get. 0. Nada. Nothing. The academic benchmarks for 1.5 trigonometry strictly require evidence-based reasoning. Rushing without any structure is absolutely fatal to your score. Let's pause for just a quick second. If you want to stop serving up average grades and finally unlock the secret recipe for an A-star, make sure you subscribe to Ace the Exams at @AceTheExams right now and hit that notification bell. We are constantly auditing these tough topics so you never fall into these sneaky examiner traps. All right, let's get back to the makeover. Section 3, recooking the response using the procedural framework. So Alex and Sam are now trying to recook this paragraph. They finally factored the quadratic to find that sin x equals 0.5 or -1. Awesome, right? Except their text flow is completely chaotic. An examiner won't be able to follow this logic at all. So I'm giving them the inside secret, the 5-step standardized procedural framework straight from the core principles of the syllabus. Step 1, identify key elements. Step 2, apply relevant principles. Step 3, execute with clear working. Step 4, verify results. And Step 5, present in the appropriate format. By forcing their messy thoughts into this specific sequence, we immediately bring order to the chaos. Now, to truly elevate this rewrite into that top mark band, we have to inject evaluative thinking. It is not enough to just do the math. You have to question assumptions and justify your decisions with rock-solid evidence. Why did you discard that negative root? Why is that specific angle outside the given domain? Explicitly stating your reasoning using comparative connectives, that is exactly what transforms an average response into a masterclass answer. Section 4. It's time for our interactive taste test. Let's do some viewer challenges. Okay, here is challenge 1. I want you to imagine a 60-second visual countdown timer ticking down in your head right now. Your goal, find the winning argument point in this data table that secures the mark. Take a really close look at the extracted data where sin x equals 0.5, and then look at the logical assumptions listed right next to it. Have you spotted it? The winning point is right there in step 2. It's explicitly stating that because the domain is restricted to 0 to 90 degrees, only the base angle of 30 degrees is valid. Extracting and interpreting that specific relationship is exactly what gets you the mark. All right, moving right into challenge 2. Take a close look at this supposedly perfect paragraph answering a trigonometric equation. I mean, it looks beautifully structured, right? But there is a fatal contextual flaw hidden in there that forfeits 5 whole marks. Do you see it? Let me highlight the error live for you right now. The student flawlessly solved for x to get 30 degrees, but they completely failed to notice that the original question explicitly asked for the answer in radians. They forgot to check the format and presentation, which, if you remember, was mistake number 2 on our principal examiner warning list. And finally, section 5, the 5-star presentation. Let's unveil the perfect answer. Alex, Sam, and I have officially transformed that messy 0-mark disaster into a flawless full-mark response. It clearly deconstructs the given information, it executes the analysis with precise algebraic notation, and it explicitly justifies the final angles based on the domain restrictions. It perfectly hits all the cognitive domains. I always remind my apprentices of this vital truth. Top-performing students exhibit connected conceptual understanding. This level of mastery, where you aren't just memorizing random formulas, but you're truly understanding the underlying theoretical architecture, that is what Cambridge mathematics truly rewards. When you have that, you can transfer these skills to completely unfamiliar context and still achieve top marks. As we wrap up this audit, let's lock in our core academic benchmarks. Here are your 3 golden rules of exam prep. Rule 1, always, deconstruct the question first. Rule 2, extract relevant data systematically. Please don't just guess. And Rule 3, execute with clear notation and show all of your working to secure those absolute lifesaver method marks. Make sure this is your ultimate takeaway today. Well, if you found this grade makeover kitchen audit helpful, please make sure you subscribe to Ace the Exams at Ace the Exams. Turn on those notifications and drop a comment below letting me know which subject and which level you find the absolute hardest. We'll be sure to tackle it in a future explainer. I'm going to leave you with this final provocative thought. Now that you have this secret recipe for analytical depth and evaluative thinking, what unfamiliar context will you apply your new conceptual understanding to next? Don't let your next exam paper intimidate you. Go out there, deconstruct it, keep learning, keep analyzing, and I'll see you next time.